Okay, so let's look at SU2 matrices. So these are 2 by 2 matrices. So let U be, say, alpha, beta, gamma, delta, where alpha, beta, gamma, delta are complex numbers. Okay. So we know that U dagger is then going to be alpha star, gamma star, beta star, delta star. Okay. So then U dagger, U is 1, which means that the left-hand side is alpha squared plus gamma squared mod alpha star beta plus gamma star delta. And here we get beta star alpha plus delta star gamma. And here we get beta mod squared plus delta squared. And this is equals to 1, 0, 0, 1. So initially we had 8 real parameters, right? But here we see that this is one condition. This equals to this. This is one condition. This is another condition. And this guy, beta star alpha plus delta star gamma equals to 0. These is 2 conditions, right? So this is one condition. This is one condition. This is 2 condition, right? Because also this equation is the same as this equation. They're just complex conjugate. They have the same content. So we get 4 conditions on 8 parameters. In addition, we have determinant of U equals to 1. This is one condition. Okay, you can show that to be a one condition. And then you basically have 8 minus 5 equals to 3 independent parameters.
Sir, shouldn't it be 8 minus 4 because since those 2 conditions are just same thing?
Yeah, that's why I've written 2 here. So this is 8 minus 4, but this is an extra condition. It's not contained here. Okay. Because these just come from unitarity.
Sir, basically my question was that since they're the same condition, they don't really reduce the number of independent variables. So 1, 2, 3, all 3 together should have 3 independent conditions, and the determinant one should add up to like 3.
No, this is a complex condition. Sorry. This is a complex equation. These are real equations, but this is a complex equation.
Oh, okay, yeah.
Yeah? Okay. All right, so now that we have we also have this formula for the inverse matrix, right? So if I use the fact that it's a determinant of U is 1 and write what the inverse is, then this is delta minus beta minus gamma alpha, okay? This is just the inverse matrix. Now we know that U dagger is equal to U inverse. So if I look at U dagger and look at U inverse, then I get that A star is equal to delta and gamma star is equals to minus beta. So I if I use these conditions in U, then U becomes alpha beta minus beta star alpha star. So here alpha are two parameters and beta is two parameters, right? So now if I say determinant of U equals to 1, then it's a real condition, and we can see that now. It becomes alpha squared plus beta squared is equals to 1, right? So what we have done here is that we have used the fact that U inverse is U dagger to go down from 8 independent parameters to 4 independent parameters. And then we are writing this we are showing that these 4 independent parameters, we can impose one extra condition, and that extra condition can be written like this, right? Do you understand this, what I'm saying?
So is this a sixth constraint?
No, I'm just, so what I'm doing here, so up until this point, let me just draw a line. We have established that our, the dimension of SU2 is 3. Okay, although I have not shown that this equation is a real equation, but just take it for on faith, okay? So now I am doing this all over again, but I have a different agenda in mind. I'm doing the counting again. All right? But I have a slightly different agenda in mind. Okay, Saif?
Okay, I see.
So I am starting with U inverse. So using the formula for the inverse of a matrix, I can write U inverse. U inverse in this way, right? Do you understand this, where this formula came from?
Yes.
It's a usual minor and all that stuff that you learn in linear algebra class. And you know that U is alpha, beta, gamma, delta, and therefore you can figure out what U dagger is, and then this is what you get from this equation. So I use this to get rid of 2 of the complex parameters in U and write U in terms of alpha and beta. So I've written U in terms of 4 parameters, not independent. And I have one further condition to impose. That condition is the determinant of U is 1, which in this parameter comes out to this. Okay? Do you follow?
Yes, sir.
Okay. Now, let's me express alpha as, say, x1 is a real number, x2 is a real number, and beta as x3 plus I of x4. So now here, x1, 2, 3, and 4 are all real numbers, okay? So if I now express this equation in terms of 4 real numbers, what do I get? I get x1 squared plus x2 squared plus x3 squared plus x4 squared equals to 1. Do you know what this equation is? What does it describe, this equation?
Sphere in 4D, or I mean a spherical surface.
Okay, what is the dimension of the sphere?
3.
So
4-dimensional hypersphere.
Yeah, so this describes an S3. Therefore, we have established that the parameter space of SU2 is a 3-dimensional sphere. Okay. So this is basically the most important result for today. And in next class, we will show how to derive the manifold for SO3 from this. Okay, any questions?
I have a question.
Yeah.
Is it possible to quickly remind us what exactly a manifold is?
Yeah, a manifold is a topological space which is locally Rn. So if you have an n-dimensional manifold, then it means that you can locally find coordinate charts which are Rn. So for example, this is a manifold. This is not a manifold. Why?
Point of intersection, it's not locally Euclidean.
Yeah, here it is not R1. Whereas, this guy is locally always R1. Okay?
So a circle would also be a manifold.
Yeah. Okay, any more questions? Okay, before I take more questions, I think let me just quickly take the attendance, and then we can, if people have to go, they have to go.